Right, now we're going to solve some word problems using the measurement data. So we're just going through and taking a look at the data and um, solving some problems. So as we look at the data on the rainfall for the Amazon was measured and recorded for 30 days. So we know it's 30 days. So there should be 30 data points here. The results were displayed in a line plot. What can you tell about the difference in the amounts of rainfall? And this is just a general statement. So you can say anything you want, like the highest recorded amount of rain was most frequent amount of rain recorded was 1.5 inches. The least amount of rain recorded was 3/4 of an inches. The most amount of rain recorded was 2 inches. All sorts of different things you can say looking at the data. And what is the difference between the greatest amount and the smallest? That we take the largest amount, which was, the largest amount was 2 inches, and we subtract the smallest amount, which is 3/4 of an inch. And when we subtract 2 minus 3/4, remember we're going to have to borrow. So we have 1 1/4 is the difference between the largest and the smallest amount. How can you use measurement data represented in a line plot to solve a problem? Bruce measured the daily rainfall while working in Costa Rica. His line plot shows the rainfall for each day in September. What is the total rainfall for the month? You can use the line plot to make a frequency table. So you can see they've made a frequency table. And in the frequency table, they're going to extrapolate or multiply out each amount, add it all together, and they wind up getting a total for the total rainfall. Oops, wrong way. Yikes, sorry about that. Can you find it without multiplying? Sure you can. You can use repeated addition if you feel like doing that. It'll take you forever, but you can use repeated addition and add all these values together. And looking at the next on the guided practice page, use a line plot showing how many grams of salt were left after liquids in various containers evaporated. You're going to see line plots are used a lot in science. How would you find the difference between the greatest and the least? We just did that on the last problem. It's kind of repetitive. We look at the greatest, which is 7, subtract out the least, which is 1 1/2. Remember, 7 minus 1 1/2. We're going to rename 7 to 6 and 2 halves. So I can subtract 2 over 2 minus 1/2 is 1/2. So my answer is 5 1/2. So we subtract the greatest minus the least. Doesn't matter how many times it occurs, because the question is, what's the difference between the values down here? It doesn't care about what's up there. Write a problem that can be answered using the line plot. You can ask, what is the greatest amount of salt left? What is the least amount? There's lots of different things you can write. Write and solve an equation that represents the total number of grams of salt left. So on this, we're going to have to go through and we're going to have to count how many dots we have. So we have, going from left to right, we have 7 at 1 1/2 grams plus 2 times 4 grams plus 3 times 6.5 grams plus 7 times 5 grams. And we add all that together and we wind up with 73 grams altogether. How many grams will be left if 2 of each of the container were used? So 73 times 2 is 146 grams. So if you want to go through and this kind of a problem, you can actually solve. 7 times 1 is 7. 7 times 1/2 is 3.5, so you can add that together, or you can actually do the multiplication of fractions. 7 times 3/2 equals 21/2, and so on. You can also do this on a calculator. If we were in school, I would have you whipping out your fraction calculators to do this, because we're more worried about interpreting than we are about the process of doing the math. So you can use a fraction calculator on this if you'd like. That's it.